In this problem, we're going to use the binomial distribution to find probabilities. The binomial distribution is a discrete probability distribution. We're given that 70% of married couples paid for their honeymoon themselves. You randomly select 20 married couples and ask each if they paid for their honeymoon themselves. Find the probability that the number of couples who say they paid for their honeymoon themselves is A, exactly 1, B, more than 1, and C, at most 1. Okay, so the first thing we want to do is identify the pieces needed for the binomial distribution. N will be 20. P, the probability of success in a single trial, is 0.7. And Q, the probability of failure in a single trial, is 0.3. Now for the calculator, we don't need Q, but if you wanted to use the formula by hand, you would need Q. And then X takes on the values 0, 1, 2, 3, and so on up through 20, meaning that X takes on the value 0 for no couples out of 20 paid for their honeymoon themselves, and then one couple out of 20 paid for the honeymoon themselves, and then so on up to all 20 pay for the honeymoon themselves. Okay, so for part A, you'll see that we want to find the probability that we get exactly one couple that pays for their honeymoon themselves. So we're finding the probability X takes on the value exactly equal to 1. So on your calculator, we're going to go to our distribution menu, which is your second VARS key or VARS key, and we want to arrow down until we find binomial PDF, our binomial probability distribution function. Whoops, I went too far. Okay. And once you choose that, you're going to need to put in the parameters. You're going to first put in N, and then comma, and then the probability of success in a single trial, and then X, and then close the parentheses. So I'm going to put in 20, and then a comma, and then P, which is 0.70, and then comma, and for this problem we're looking for one couple. Okay, so X takes on the value of 1, and then close parentheses, and then hit enter. Now you see that probability is very small. The calculator gives that probability in scientific notation. That's approximately 1.63 times 10 raised to the negative 9th power. For part B, we're asked to find the probability that the number of couples who say they pay for their honeymoon themselves is more than 1. So we're finding the probability X is greater than 1. Now we're not including the case of equality with 1 because we're asked to find the probability of more than one couple. So in other words, X is taking on the value from 2 up through 20. So we could use the binomial PDF and find the probability X is equal to 2 plus the probability X is equal to 3 plus the probability X is equal to 4 and so on up through X is equal to 20 and add all of those up. However, that would take a long time. So instead, we can use the complement. In other words, translate that problem as 1 minus the probability X is less than or equal to 1 and use the cumulative distribution function. Remember, the cumulative distribution is like a running total. So we're letting X take on the value of 0 and 1, adding those together and then subtracting from 1. The calculator will do that for you. So I am going to go 1 minus. Now I need to get that binomial CDF. It's under the same menu that you found the binomial PDF. So I'm going second VARS key, and I'm going to arrow down until I find binomial CDF. Oops, again I went too far. Okay, I'm going to put the parameters in the same order. I'm going to put in 20, and then I'm going to put in the probability of success in a single trial. And then again, for this problem, I'm putting in 1. Now this doesn't mean I'm finding the probability x takes on exactly the value of 1. What this means for the binomial CDF is that I am telling the calculator to add the probabilities x is equal to 0 to the probability x is equal to 1. Okay, so in other words, I'm getting a running total and I'm subtracting from 1. Okay, so using the complement in this case is going to be the shortcut. Okay, so press enter and I get a probability that's very close to 1. In other words, it's extremely likely that I'm going to get more than one couple who said that they paid for their honeymoon themselves. And then part C, I want to find the probability x is at most 1. So again, I want to use the binomial CDF because at most 1 means x is less than or equal to 1. In other words, I could sum the probability x is equal to 0 to the probability x is equal to 1. I could input those separately using the binomial PDF, and then adding those probabilities together will get me the correct answer. However, I'm going to use the CDF again because that will be the shortcut. The CDF is a running total. It sums up the probabilities. So I'm going to again go to my distribution menu and arrow down to binomial CDF and put in the parameters. I'm going to put in 20, comma 0.7 and 1. So that is going to give me the sum of the probabilities. The probability x is equal to 0 plus the probability x is equal to 1. Okay. And you'll see that the answer is in scientific notation. It's about 1.66 times 10 to the negative 9th power. Now those answers are all valid probabilities. Remember, a single probability needs to fall between 0 and 1. In other words, you cannot have a negative probability and you cannot have a probability greater than 1.